Okay, in this video we're going to cover a little bit about wire connectors, connections, and a few other little tips that can help you do a nice job in your wiring. First off, wiring must be marine grade for a boat. At a quick glance, this is not cheap wire. This is high quality wire, general purpose, that's used in the automotive field. And you will notice that it untinned plain copper wire, nothing special about it. The insulation is a very high quality on it. This wire is Anchor Marine, which is the wire I use almost exclusively. It's excellent quality marine wire. It has very good insulation on it, and it is tinned. All right, where's my picture? There we go. Tinned copper. You see the silver appearance. That tinning helps protect the wire from corrosion, resistance, the wire turning green. It also improves the connections in the connectors when they're crimped. Wire sizing. Don't go overboard in your wire sizing. Use a wire calculator. I will put one up on my website and YouTube for a link to a good one. Calculate every device you're going to use. Make a list of everything that's going to go in your electronics wiring system. Write down the amp draws, the max amp draws for each and every piece you have. Add it up, see what your total amperage is. Then calculate the length of your run that you're going to make from your battery to your fuse box. How many feet is it? Depending on the calculator, some of them you have to put the round trip distance in. 15-foot run would be 30 feet. The calculator I like, you put one-way length, which would be roughly 15 feet from the fuse box to the battery. Then look on the chart, find out what size of wire you're going to need to maintain approximately a 3 to 4 amp voltage drop in the system, which is great. So a lot of these companies now are going way overkill. Seems like people are thinking bigger is better. Well, if that was true, we would be using deep sea rods for punching for bass fishing. There's a right size of rod and reel and line for every job we're going to do. There's a right size of wire for every job we're going to do. Use the calculators to help you determine what the correct size is. Going overboard with wire size just puts more copper in the system, which collects radio frequency interference and EMI, electromagnetic interference. It can actually add to problems concerning RFI. It will have a lower voltage drop, that's true, but how perfect do you need to get it? 3% is absolutely great, and most systems will work just fine at 10% drop in the system. That would only give you about 1.3 volts drop total, which is quite acceptable. Okay, now on to connectors. This is where I see a lot of issues on it. This connector looks like an expensive connector. I gotta get a better picture. Looks like an expensive connector. It's not. It's one of the cheapest ones made. And the first thing you'll notice about it, it's magnetic. You do not want iron core connectors in your boat. They need to be tin copper, always. This connector also looks like a pretty decent connector too on it. It's not magnetic, that's a good thing. But here's the problem with this type, and these are very common on cheap connectors. When you look closely, you see that seam, that split seam. I'll give you an end view here too. You can see that slit. How these connectors are designed, they take a flat piece of metal, they roll part of it into a circle, to make the base where it's going to be crimped. Then the rest of the flat, they punch a hole in it for whatever stud size that you need. They're lousy. This crimp will not crimp and hold tightly. You can pull on a harness and pull the wires right out of them after a little bit of time. Don't use them. Use, preferably, really good quality connectors that have shrink tube on them. And if you look closely at this connector, they're hard to see in this video. You need really good close-ups. But you will see the walls are fairly thick, and if you rotate it, you won't see any seams in that connector. It gets an extremely good, tight crimp that will not fail on you with the right tools on it. Here's another one that's uninsulated. And uninsulated connectors have a purpose on it. They can make very compact connections, like for wire splicing. You can take a piece of shrink tube, put it on the wire, use a non-insulated connector, and this type of crimper to crimp them. This is the best tile. Got the big tooth in here. And when you squeeze this thing down, it gets a very good crimp. I hope you can see that well. It uses all that space up. It'll crimp that wire where it will never come loose. A piece of shrink tube over this connector, and it's very, very compact. It's very good if your wires are too short and you have to extend your harness, you got to add a piece of wire. Do it this way and put shrink tube over it instead of using the shrink type, which are much bulkier. Okay, tools. You saw that crimper that I use for non-insulated, and I also use that for 18 gauge and smaller wiring. Because the wiring is so tiny, you have to really, really get something like that to push the metal in and lock it down good and tight. Strippers. Cutters and strippers. Buy good ones, don't buy cheap ones. A combination of cutting a wire. You can use the parrot bills on them to twist the wire. These are very, very sharp cutting edges in there, though they cut that insulation very clean, and they got a slot for every gauge size you're going to be working with on it, except for the big cables on it. So get good ones, don't get cheap ones. This is my favorite pair of crimpers. I use these more than any other crimper. Primarily, these are for 10 through 16 gauge wire. And you will notice the red dot, the blue dot, and the yellow. And these shrink connectors, the red ones are for 18 to 22 gauge wire. The blue is for 14 to 18, I'm sorry, and the yellow for 10 through 14 on it. Use these, each location is for whatever color your shrink connector is. If you got a blue connector, use the blue one in the center. If it's a yellow, use the bottom one, the yellow one on it. These also, when you buy these type, these have jaws that pop in and out, and they come with a full set of 6 different mandrels for all different types of connectors. And they're easy to swap out for any type of connector that you get. The set I have has 6 sets of mandrels that come with it. This is what I'm using 90% of the time. Okay, I forgot something a little bit ago. I want to bring this back at this time, back to the wiring connectors. These connectors here is one I did not cover. This connector, if you look closely, you'll see a seam coming right down the center of it. That seam is welded shut. I drove this all through the inside of this with a hammer, and it did not open that seam up like the seam type I showed you earlier. These are still very good. Solids are even better, but these are great. And they're more common with the welded or brazed seam on them. Now, the last one for crimping is a hydraulic crimper. These jaws, they come with several sets to do everything from 10 gauge down to 1/0 very, very large battery cable. So you put the set of jaws in that's working with the lugs or terminals that you're using, and you've got the aid of hydraulic pressure to get it crimped extremely tight. Those larger cables, you cannot hand crimp them without, they do make a hand tool. It's about 3 feet long with giant jaws for hand crimping them, but they're bulky. You can't get them into tight places on it. This works way better on it. Okay, I'm going to show you a couple little tricks. One of them is, I see posts all the time, guys saying, hey, I've got to get small 18 or 20 gauge wire connected to 10 gauge wire I've run, which usually that's 10 gauge wasn't required if you were trying to connect to 18 or 20. But there's a quite easy way to do that. And you strip the small wire, you strip the strong wire to longer than the barrel of the crimping barrel in here, because you want it to pass all the way through the other side. So you push this through it, rotate it, because there is an obstruction in the middle, but you rotate it, wiggle it, it'll go all the way through, and you even want to slide the insulation in on that side. Okay, the other side, now that wire is sticking out this other side. So I'm going to put this in, and it's going to overlay that small wire. Be careful not to push your strands back. Rotate them, twist them back and forth, get them lined up. Push this one all the way in. Now this wire is overlaid with that one. Yellow connector. So I'm going to use the yellow dot, and I'm going to crimp the sides where the large wire is in, and it overlaps that small wire. Okay, that's crimped. Now you will find this wire is firmly crimped in place. Not a problem. You have overcome that sizing issue. Now I'll crimp down the other side. That's more for cosmetics than anything. Crimping the other side. Now the heat gun, or small propane torch, which I use a lot of. And we shrink down the tubing. Shrink down the tubing on both sides. And you will see that the adhesive in there run, it'll turn crystal clear when it's shrunk all the way. There won't be any dullness in it. That's the adhesive sealer that's on inside this on it that seals this up. And while this is still warm on the small wire, I'll take it, roll it in my fingers on it when it's still warm and soft. And that presses it down against this wire. What that does is this has a little give in it, because right where this goes into the middle connector at that rigid point, that's where a wire tends to break on a connector if it breaks. If this is shrink down and overlapping, this is what we call strain relief, because it has some moving, it takes the stress off that connection point where it was crimped tightly. So that gives you a perfect way of doing it.